Hello, and welcome to Fun Facts Online, where we dig into the most fascinating stories from science and history. When you think of an archaeologist, what comes to mind? Probably someone in a dusty hat, with a whip and a trowel, maybe running from a giant boulder in a temple. For decades, that romantic Indiana Jones image has defined our view of uncovering the past. But what if I told you the biggest discoveries today aren't being made with a brush and a spade, but with lasers, satellites, and artificial intelligence? A new golden age of archaeology is here, and it's happening not in dusty trenches, but on computer screens. Today, we're uncovering the lost worlds that technology is revealing, and transforming everything we thought we knew about human history. For centuries, the biggest secrets of our ancestors were locked away, hidden beneath impenetrable jungle canopies, or the shifting sands of the desert. But now, we have a key. It's called LiDAR, which stands for light detection and ranging. Imagine flying a plane or a drone over a dense forest. Attached to it is a device firing millions of laser pulses down towards the ground every second. Some of these laser beams bounce off the top of the trees, but many sneak through the leaves and branches, hit the forest floor, and bounce back up to the sensor. By measuring the tiny differences in time it takes for these pulses to return, computers can digitally strip away all the vegetation. They essentially make the entire forest invisible, revealing a perfect 3D map of the bare earth underneath. And what we're finding is blowing archaeologists' minds. Take the legend of the city of the monkey god in Honduras. For decades, it was just a myth. A white city lost in the Mosquitia rainforest. Explorers searched for it on foot with machetes and came up with nothing. Then, in the 2010s, a team flew a plane with a LiDAR sensor over a remote valley. The results were staggering. Once the computer processed the data and removed the jungle, there it was. The clear outlines of plazas, earthworks, mounds, and even a pyramid. A legendary lost city found not by treasure hunters, but by laser beams. But that's not all. LiDAR has completely rewritten the story of the ancient Maya in Central America. We used to think of the Maya as living in a few, relatively isolated city-states, but recent LiDAR scans in northern Guatemala have revealed something incredible. A sprawling, interconnected network of tens of thousands of previously unknown structures. We're talking about huge cities, towns, farms, defensive walls, and complex irrigation systems, all linked by causeways. One massive site, stretching over 650 square miles, showed that this complex society was thriving as early as 1000 BC. The population wasn't in the thousands, it was likely in the millions. A true megalopolis hidden under the trees. Even famous sites are giving up new secrets. At Angkor Wat in Cambodia, we all know the magnificent temples. But LiDAR has shown us that those temples weren't isolated monuments. They were the heart of a vast, sprawling urban center, with roads, canals, and neighborhoods that housed up to 900,000 people. The lasers even uncovered a massive water management system, whose failure, possibly due to climate change, may have led to the city's decline. Seeing through trees is one thing, but what about seeing from space? That's where satellite archaeology comes in. From hundreds of miles up, satellites with powerful cameras and infrared sensors can spot subtle clues on the Earth's surface that are invisible from the ground. Things like slight changes in soil moisture or how vegetation grows can indicate buried walls or entire settlements. The pioneer of this field, Dr. Sarah Parcak, has used this technique to make unbelievable discoveries in Egypt by analyzing infrared satellite images, which can highlight dense materials like mud brick walls buried under the sand. Her team has located thousands of undiscovered tombs and settlements, and even what might be lost pyramids. She mapped the entire ancient city of Tanis, revealing its streets and houses without ever setting foot there. We've even weaponized old spy technology for good. Declassified images from the Corona spy satellite program in the 1960s have given us a snapshot of the Middle East before modern development, preserving a record of ancient sites that have since been destroyed. Back down on Earth, the archaeologist's new best friend is the drone. Drones are cheap, agile, and can fly low to the ground, capturing incredibly detailed images. Using a technique called photogrammetry, where hundreds of overlapping photos are stitched together by software, drones can create stunningly accurate 3D models and maps of a site. In one study in England, a single drone survey increased the number of known archaeological sites in the region by 50%. They're perfect for monitoring ongoing digs or checking on fragile sites without causing more damage. So we've looked from the sky and from space. But what about looking directly underground without digging? This isn't science fiction. It's called geophysics. Think of it like giving the Earth an ultrasound or an X-ray. One of the most powerful tools for this is ground-penetrating radar, or GPR. It works by sending pulses of electromagnetic energy into the ground. When these pulses hit something, a buried wall, a floor, a ditch, they reflect back to a receiver. Different materials reflect the waves differently, allowing archaeologists to build a 3D map of what's hidden beneath their feet. The most mind-blowing example of this comes from Faleri Novi, an ancient Roman city north of Rome. Instead of digging for decades, a team of researchers towed a GPR instrument behind a quad bike, systematically scanning the entire 75-acre site. The result was a complete, breathtakingly detailed map of the entire city. They found a bath complex, a market, a temple, public monuments, and even the intricate network of water pipes running beneath the streets. They could study the city's layout and evolution in a way never before possible, challenging old ideas about Roman urban planning, all without turning a single spade of earth. It's a complete game changer, allowing us to see ancient cities not as ruins, but as the complete, complex organisms they once were. Now, all of this amazing technology, LiDAR, satellites, GPR, generates an unbelievable amount of data. A single survey can produce terabytes of information, billions of individual data points. So how do you turn that mountain of data into a discovery? This is where the digital revolution really kicks in. Using techniques like photogrammetry and laser scanning, researchers can create hyper-realistic 3D models of everything from a tiny arrowhead to an entire landscape. These digital replicas allow us to study fragile artifacts from any angle without ever touching them, or to digitally reassemble shattered pieces of pottery to see what they looked like thousands of years ago. And it gets even cooler. With virtual and augmented reality, we can now step inside these reconstructions. Imagine walking through the halls of a Roman villa, seeing the restored frescoes on the walls, or holding a virtual replica of a Mayan pot in your hands. This isn't just amazing for researchers, it's revolutionizing how we all can experience the past. And then there's the brain power of artificial intelligence. AI and machine learning are the perfect tools for sifting through these massive data sets to find patterns a human might miss. AI algorithms can be trained to look at satellite imagery and predict where undiscovered sites are likely to be, with incredible accuracy. In ancient Mesopotamia, an AI system identified potential new sites with 80% accuracy. AI is even being used to piece together history itself. In Pompeii, AI-driven robots are painstakingly reassembling ancient frescoes from thousands of tiny, mixed-up fragments, a puzzle far too complex for any human to solve alone. This technological explosion is incredible, but it's not without its problems. First, there's the digital divide. A LiDAR scanner, or access to high-res satellite data, can be incredibly expensive. This means well-funded institutions in wealthy countries have a huge advantage, while researchers with fewer resources get left behind. Then there's the data itself. Where do you store terabytes of information from a single site? How do you make sure it's properly archived and accessible for future generations? The modern archaeologist now has to be part data scientist, part computer programmer. But perhaps the most complex challenge is an ethical one. When you create a perfect digital replica of an artifact, who owns it? The museum that holds the object? The researcher who made the scan? Or the community where the artifact came from? This has led to the complicated idea of virtual repatriation. Some argue that sending a digital file of an object back to its community of origin is a form of return. But many others argue that a digital copy is no substitute for the real thing, and that this could be a way for museums to avoid the difficult but necessary conversations about returning physical artifacts that were looted or unethically acquired in the past. There are no easy answers here, and it's a debate that is reshaping the very ethics of archaeology. So where do we go from here? The pace of innovation is only getting faster. In the near future, we can expect to see fleets of autonomous drones mapping vast, remote landscapes, and maybe even tiny robots that can carefully excavate the most delicate sites. New sensors might let us see even deeper underground with perfect clarity. The ultimate goal for some is the digital twin, a dynamic, living digital copy of an entire archaeological site, updated in real time with environmental data to help us preserve these precious places forever. From lasers that see through jungles to AI that pieces together the puzzles of the past, technology is giving us a new set of eyes to look back in time. It's not replacing the archaeologist, but it is giving them superpowers. The fundamental human desire to understand where we come from remains the same. But now, thanks to this incredible toolkit, the next lost city or the next great secret of human history might not be buried under the sand, but waiting to be found in a line of code or a flash of light from the sky. Thanks for tuning in to G Fun Facts Online. Join us next time as we uncover more amazing stories from our world.